Today, we are going to talk regarding one of the nice concept, which we call it ISR or Interrupt Service Routing. Uh, Mainly, you know that this process is one of the concepts that which help uh, any CPU to work faster. But before going deeply to the concept, let us have some simple story. Okay. Uh, as I written here, you consider we have the fast moving car. If suddenly the car that we have hits by another car in the opposite direction, the first thing which will be happen is that the accelerometer sensor present in the car sense a sudden deceleration and triggers and external interrupts to the microcontroller present in the car. Then the MCU will produce an electrical signal to deploy the airbag immediately. And microcontroller, which we have in our car, monitor many things simultaneously, like sensing the speed of the car, checking other sensors, controlling the air conditioner, temperature, etc. So what makes certain opening the airbag in second? This signal, we call it interrupt signal, which is used for the higher priority work. Keep this idea in your mind or this example in your mind. Let us see as another example is suppose something that we have nowadays for our daily life is our mobile phone. You see that in the touch screen of our mobile phone, which has the highest priority to see the touch sense. And almost every electronic device has some kind of, we can interrupt to interrupt the regular process and do some higher priority things on the particular event. The regular process is resumed after serving the interrupt. So technically, we can say interrupt is a mechanism which an I/O or input output and instructor can suspend the normal execution of process and get itself serviced like it has the higher priority. For example, a process doing the normal execution can be interrupted by some sensors to execute the particular process that is present in ISR or interrupt service routing. After executing this ISR process, can again resume the normal execution. I have even one better example if you want to know. Suppose you are waiting for some guests to come to your house. Okay, we have two options to work. One is that you can sit near the door and every second, every millisecond, every microsecond, check the door that guest is coming or no. This is one possibility to doing this process or hosting work. Another process is that you can do your regular work in your home, and when he's coming, he can knock the door and you can open it. Intro process is exactly knocking the door. When somebody knocks the door, then you open. Otherwise, you will do your regular work. The example that we had recently, I mean, the car example is also like that. You have the accelerometer that it's working on the proper mood and regular work. But if anything happened, any signal happened, it will stop the routine work, come and see what is the purpose. Suppose this is the airbag signal, then come back, uh, do that job, give the proper output to that signal, and then come back and again doing the job. Or for the next example, I mean the after the car example, I give you one more example for touching sensors of your mobile. When your mobile phone, you don't touch the screen, maybe the LCD is turned off. It can do its work, do the regular work. But suddenly, if you touch the board, then what will happen? It will turn on the backlight and then show you the screen. These are the nice sample or some we can say daily example that we have about the concept of interrupt. Then we can say on a very basic level, an interrupt is a signal that interrupts the current processor's activity. Means that it will stop the current routing of work, and it may be triggered by some external event, suppose changing in pin state, or some internal event that we call it timer or software signal. Once this trigger will happen, an interrupt pauses the current activity and causes the program to execute a different function. This function we can call interrupt handler or interrupt service routine, or as the short form, we can call it ISR. Once the function is complete, the program returns to what it was doing before the interrupt and was triggered. Exactly like the guest example. When your guest leave your home, then you will do your job. You will do your regular job. It's not something that you are pending all the things that you have. Let us see more deeply what is an interrupt and what does an interrupt do for the flow of work. As we say, interrupt is just pausing the current status of the work, and the interrupt will stop the flow of work, go to suppose another algorithm, another job, another task, do that, and again turn back. Okay. Sometimes interrupt used to overlap the computation and input output. For example, would be console input output, printer output, and disk access. Let me tell you one thing. I think most of you use the printer. When you will install it to your computers, I mean, you put the USB cable there, you will hear one sound that uh, printer will generate, and it will inform you that, okay, I'm present. This signal, which people they call it handshaking signal, means that the printer will shake his hand and say that I'm ready, something like that. This signal is based on interrupt. Okay, some interrupt will generate by the printer microcontroller or somehow processor and inform the computers that I'm there. Uh, which normally this work handled by OS and sometimes under the Unix and NT really coded by the some ordinary programmers. In embedded system and real-time system, part of the normal working is based on this interrupt. But which type of interrupt we have? What we learned here now? Okay, we have two type of interrupt. We have one type of signal which stop our routine work and force the processor to first do that job because it has the high priority or most important things to do. That was the definition for the interrupt. And now we are going to say that which type of interrupt we have. We have two type of interrupt. First one, as I written here for you, we have the hardware interrupt, which it happened when an external event is occurred like an external interrupt pin change its state from low to high or high to low. This is the hardware part. And we have some software interrupt, which it happened according to instruction from the software. For example, timer interrupts are one of the famous example for uh, software interrupts. Let me tell you more. Serial programming is one. In analog reading, you can have. In SPI programming, you can have. In I2C programming, uh, you can have. These are all the things that I want to tell you that wrap and engage with the interrupts, and you can find them in various job and various place in your processor. Okay. Um, then the conventional or previous method, people call it pooling. Why they call it pooling? Because it's make your CPU uh, bulky, and it's waste lots of time from your CPU. I mean, suppose have the example of the guess. If for the work option one, every time I check the door and see that is anybody coming or anybody coming, yes or no, anybody coming, yes or no, it will waste all the time or all your effective time that you can do another job till entering your guest. This work we call it pooling. Pooling means that you it's something like one person pull and just overload the CPU by that. This is the method. And what about the interrupts of that? Interrupt is exactly you do your regular work, some person will come, knock the door, you open it, and then what will happen? Do the job, answer him, invite him, do the guesting job, and then finish. Again, do your routine work. And sometimes, interrupt is an asynchronous subroutines call and triggered by hardware events that saves both return address and system status. Means that sometimes in the memory of the CPU, you should know what did you do before interrupt, and when it's finished, where you should return back. Okay, which people in the CPU, they make some process that they can save this address and come back exactly from the place that they live, and then finish the current instruction, save minimal state information on stack, transfer to the interrupt handler, also known as interrupt service routing or ISR. Um, and then these are exactly what will happen with the interrupt service routine, and what we should do. Let us work with some complex hardware setup. Suppose I have device A, device B, some interrupt controller, and CPU. This is exactly what we have in processor, not some small one like Arduino. This is the bigger platform. Suppose that you have something like ARM processor that you have inside of your mobile phone or inside your computer, I mean personal computer or PC. It's exactly like this. Any device have one IRQ or interrupt routine request. Whenever it will happen or anything's happen to that, you can see that through the interrupt controller, the data will transfer to the CPU. Then what is the job of interrupt controller? Interrupt controller should see that which request or which IRQ has the priority, and also which one is activated first. Let us see. Suppose in your computer, if you can reset your computer and also press the button A on your keyboard at the same time, the interrupt controller knows the reset as the most important interrupt routine, and then it will restart your computer. Okay. There is the list that they call it interrupt priority, and I remember when we study 8051, there was the list that show which interrupt has the priority, which one has the highest priority, and also you can tune that same provision we have for the Arduino board. But as you know, now the crystal for the Arduino is much more fast. People will do less effort on changing the priority, but if they want, they can do in the AVR platform. Um, if we think for the processor, we can have some types of interrupt like asynchronous, which will come from external source, something like IO device, and some which are not related to the instruction being processed. We can have this categorization, and for the synchronized one we can which people they call it exception. Processor can detect some exceptions, something like faults, something like traps and aborts, which they are happened in the case of CPU's job. uh, and this programmer exception, which is the request for the kernel intervention, or will happen um, in the synchronized type of interrupt. Let us see, suppose some architectural diagram of processor about the interrupt, which we can have some main memory, some central processing unit, and also um, which they are searching on the bus or system bus, which people will call it something like highway, that all of the IOs, they will share their data on this highway or this system bus. And as you can see, any IO device which is connected can send the signal, and main memory can see it. And let us summarize the concept for the interrupt that I tell you. Till now, what I tell you is related to processor, and after that, I'm going to some small chip like Arduino. But it's good for you that you know that the main program is running and performing some function in the circuit. However, when an interrupt occurs, the main program halts while another routing is carried out. When this routine finishes, the processor goes back to the main routine again. Some exception with interrupt, we can say that we have some synchronized and unsynchronized. We have some um, fault and trap, and we have some relation between exception and signal. Uh, if you have the device, that device will send you that interrupt request, and then this will go to generate the interrupts for you, and then that action will happen. If I want to tell you some important feature regarding the interrupts, I can say that interrupts can come from various sources. In the case that we are using the hardware interrupt that is triggered by the a state change on one of the digital pins. Most Arduino design have two hardware interrupts referred to as interrupt 0 and interrupt 1, hardwire to digital pins of 2 and 3 respectively. And we can say that if we think from Arduino and interrupt service, with a variety of the Arduino, we can say that in Arduino Mega, we have 6 hardware interrupts, including the additional interrupts, interrupt 2 through interrupt 5, which they are from pin number 21 to 28 to 80. Um, you can define the routine using the special function, which they call it interrupt service routine or ISR, and you can define the routine and specify the condition at the rising edge, falling edge, and both. Uh, don't worry, this is the full overview of the interrupts. We will analyze one by one, okay? And don't forget that it's possible to have the function executed automatically each time an event happens on an input pin, which is one of the best things that we can have in Arduino. Okay, before starting the Arduino part, I think let us do the attendance, and you please turn on your webcam that we can do the attendance, and then again we will go to continue for the rest of the lecture. Just till now, what I want that you uh, know what is interrupt and how it can work or how it can perform. What is interrupt and why we need interrupt? Let me once again review it for you. The interrupt is nothing by having the signal which may happen in some special case. There is one more example. See, suppose if I'm teaching you and suddenly our school dean enter the class, I should stop the class and go and speak with him because maybe some important things happen to school. But suppose if I'm teaching with you, but one of my friends will come and wants to enter the class, I should tell him that don't come. Means that because it don't have any priority now. Then don't forget, this is the difference between signal and priority of the signal. You should know that interrupt are some special or some VIP, I can call them, signal, which can be enter in your controller, and then we tune them or we will hire them to use in the case of some special job, some specific job to do. By using the interrupt, we can increase the speed of the processor and do our job fast. This is the review for till now what I tell you. But as the goal of controller that we are using the Arduino system, which in our Arduino system, we are using the ISR or uh, interrupt service also, and in them uh, we can do some nice job which can help the signal from our uh, um, output of the Arduino that we have, and it can help to increase the speed of our CPU working or Arduino working. In the other words, interrupts are very useful in Arduino programs as it can help to solving the timing program. Uh, a good application of interrupt is reading the suppose some rotary encoder or observing a user input. Generally, ISR should be as short and fast as possible. And if you sketch using the multiple ISRs or interrupt service routines, only one can run at a time. Other interrupts will be executed after the current one finish in an order that depends on the priority that they have. As I say, suppose in the case that my friends enter the room or the dean of a school will enter the room, we should find which one has the most priority and importance for us, and then do the proper action based on it. Typically, the global variable are used to pass the data between ISR and the main program. Um, to make sure that variables shared between an ISR and the main program updated correctly, mainly we will declarate them as the volatile. Remember these 2 points. We will work with them uh, later, and you will see some example regarding. Okay, then now we understand that we have the same concept of interrupt for Arduino board, but they are different in different Arduino boards. Suppose for Ono, Nano, Mini, and other 328 based microcontroller, just pin 2 and 3 will use as the interrupt. But suppose for Mega or Mega 2560 or ADK, we have six interrupt pin. Or suppose for the DUI, all the digital pin can use. For 101, all digital pins can use. This is the difference between the number of interrupt that we can have in Arduino board. But anyway, normally we are using the digital pins to interrupt in some command like these, rather than place an interrupt number directly in our sketch or programming. Then the specific pin with the interrupts and their mapping to the interrupts number varies from each type of the boards, and direct use of interrupt numbers may seem the simple, but it can uh, causes compatibility trouble when you sketch run on a different board. However, some older sketch over have the direct interrupts number and often number zero, uh, which will related to pin number 2, and number 1, which will be related to pin number 3 were used. Here I have one table which show the available interrupts that we have just for 3 boards. I bring here for you, which I wanted you note that in the table below, the interrupt number refer to the number to be passed to the commands of attach interrupt. And for some historical reason, this numbering does not always correspond directly to the interrupt numberings on the Atmega chips. Remember that these interrupts are interrupted by hardware and are very fast and can be set to trigger on an event by rising and falling, which I will tell you what are these two. ISR syntax in Arduino, it's something like this. Means that if I want to use the ISR, oh, sorry, okay. If I want to use the ISR routing, I should use this attach interrupt, digital pin, ISR, and mood. But let us see what is this syntax. In this, digital pin or first part will tell us which pin our Ono Nano should use. Suppose in Ono, we know that we just have pin number 2 and 3 to use as the interrupt. Or for the Nano, oh, it's also same. But in Mega, 2, 3, 18, 19, 20, and 21 can use as this job. Then the first part of our syntax is okay. Next part is ISR, which the function that we want to do. It means that we are using the function and sub function or routine and subroutine, and the subroutine name, whatever you put, you can put as the name of ISR. Okay, it's contain the works that you want to do. Suppose I want to clarify that if that interrupts happened for me, just turn on and off an LED. This job of turn on and off should come inside of my ISR. And for the mode, we have three modes that we call it rising, falling, and change. Rising is that when I'm going from 0 to 1 or low to high, I call this rising. Falling is that whenever I'm going from high to low, it's call it falling. And change is that whenever I go to high to low or low to high. These are the modes that I can have for my interrupt service. Then it's become clear. First part is the pin number. Second part is my function. And third one is rising or falling or change. Let us see. Okay, here also I tell you the same job and same things. We can even summarize it as pins, ISR, and mode, which generally people will use this for Arduino DUI. But for all Arduino board, people prefer to use this format of function. Okay, let us see some condition that we are using interrupt, but will happen. These are very important in the case of using the sensors and reading the data. Don't forget them. Interrupt service function must be as short as possible. Don't make the big and long interrupt coding part. This is the one. Second is that don't forget that delay function does not work inside of your ISR. These 2 points we will see later. But here let us see one example which is related to our Arduino uh, interrupt part. As I tell you, in Ono, we have two pins that can use as the external interrupt. One is pin number 2, another one is pin number 3. Then in the program also, we can first of all clear or define that int pin equal to 2. And then some volatile int state we can have, which it can be equal to low. Then in my setup, just I can say what is my output pin, suppose pin number 13. And now I should declare the input. Interrupt which pin I declare it as 2. The ISR name is blink, means this one that I wanted. Whenever it will happen, just I change my state, and I want that it will be sensitive to change. The output is this program is very simple. It's like that. Whenever anything happened or any change we have, the state of my interrupts, state of my output will be changed. Okay, just keep this in your mind. For tomorrow lecture, we have 9 example which we are going to analyze and speak regarding that and use of interrupt service. Today was some introduction for that, and tomorrow we will more focus on the application part of ISR service routing. For today, I think let us see the let us see the today clip that it's about some nice clips that people will do with the Arduino, and after that we can stop for today lecture. Okay, let us see. Okay, let us see some example or which I download for you from net, which will give you the overview about top 8 useful Arduino project from year 2020. It's here that you can see. Let us see number 8. Number 8 is dual axis solar tracker, that you know that it's very useful for energy monitoring job, or also new method of the energy, which you know that changing the place of that and tracking the place of the sun will help this tracker. Simply, you can make it with LCD and some servo motor, which I teach you, which I will teach you even for later. Here, as you can see, they have some assembly and they can do. Project number 7, it's related to the barcode-based recyclable job. You know that some garbage is the major problem for all the world, and automatic garbage collector will be the some nice job if we can do it. Look at how the system automatically, you will see that this is the system. Okay, it can push it out and it can separate it. See, oh, okay, something like sorting job. It can measure the weight, and based on the weight it will do. Project number 6 can be some IoT smart uh, dustbin, that in that you know that no need to open the recycles manually. It should sense you, or it can find your garbage and then open, something like that. When you will be near to that, it will open, and then it can turn off by the clapping, and then even when it's full, maybe it can give the alarm for the dealer or any other person that, okay, my garbage is full, then come and make it clean. Number 5 can be IR vision snake robots, which I like it. It's one of the nice jobs. It can work inside of the pipes and space, and also do uh, wall and flooring. So many things it can do. But let us see that how these maybe useful robots can work. It can have um, some motors or some servo motors, as we can see here, and it can move like the snakes and then do the jobs. And you know that some small camera on that can send you the data well. Project number 4, which it's related to the gas leak detector with auto exhaust. You know that one of the main problem that we have in industry is that alarming increase the gas pipe leakage, and here is the system that detect the gas and also activate the exhaust fan to that. You will see that through the Wi-Fi it can connect, and through the net even you can control it. You will see that when the gas is more than some standard form, it can turn on the exhaust. Project number 3 can be the smart glasses for the voltage measurement, which you know that sometimes it's very difficult to do two jobs at a time when you are measuring the voltage and do the same things. Now, if in the time of working we can look at the reading time and just measuring, it will help. See something like this. Yes, it can transfer the voltage value on the glasses of the toggles. Okay, number 2 can be the robots, Arduino self-parking car, something like that, which it will be something like this, some automobiles which is going to use of three sensors and then park itself without the uh, use of any driver for that. See, this is suppose robots, and these are the obstacle that it has. Then it can go and then tune itself and then come back and then do the parking job. Okay, and first one, it can be autonomous fire detector and execution robots, which can be very useful. In the uh, every year we have the lots of accident like that, and firemen are interface a lot of problems like this. Then robots can help them to do this job better and detects and stop the fires. Okay, maybe it will be much more faster than something that we expected with the help of Arduino board. Suppose these are some smoke stativa and this is our robots. Robots can come, detect the obstacle, and then here you will see that they create some fire. Okay, it find it, then it will turn on the pump and then kill the fire. Yes, that was some application clips that uh, I bring from various places and various things for you to read. Uh, I wish that you learned something today. As you uh, usual, I can say, if you have any question, please ask me. We don't have task for today lecture, but tomorrow we have, because I feel that the time is less for you. But tomorrow we have lots of tasks. You can do it. Please, if you have question, um, please ask me on private, and